G'day, Michael here. In this video I'm going to use a 2D package called QCAD to draw a accurate drawing, a workable drawing for a workshop application using the rough sketches I had in my previous example. Here you can see plan view, here you can see an elevation. Now I'll explain those two words. A plan view, think of the word plane. Plan is simply a variation of the same word. It's the basic meaning of like horizontal. So this drawing here shows you what you see looking down on the plane or on a horizontal flat surface. That's what this view does. So you're looking down from above to the floor. Okay, now anything that has a height involved is called an elevation. So if you've heard the word elevation before, it simply means you've got a drawing that includes a height. Now this is a perspective, so it's an elevation of sorts, but it's actually showing a third dimension, like you've got width and depth is shown sort of as diagonal lines, etc. And of course the height. Now with 2D CAD we can only draw two dimensions at one time, hence 2D. Now we have an x-axis which goes across and a y-axis which goes up. That's in the drawing package. I'm going to say all drawing packages, including graphic arts type packages, maybe like Corel Draw or Adobe Illustrator, etc. They use the same sort of Cartesian coordinates. That's another story. I'm here to explain the concept of the drawing as opposed to understanding your CAD package. Now I use a CAD package called QCAD, but there's a slightly lower featured open source package called LibreCAD. Now, where's my QCAD gone? I'll launch QCAD. There's QCAD. Okay, so now I'll launch QCAD. This is my package that I've bought. It is a fairly low cost package, but you certainly by no means don't have to even buy this package to do the job. If you're only doing a one-off job, I would recommend getting the proprietary, I'd recommend getting QCAD the way I have, because it is a little bit handier. There's a few features. One that I particularly go for is if you go to draw a line, let's just draw a line. The snap tools are quite smart. Let's say there's one line. If I want to pick this point, it'll pick the intersection. If I draw another line like that, it'll also pick the intersection. It should also pick a midpoint on the line. So its snap is what you call auto snap. See this auto snap function. LibreCAD, you have to pick these snaps. Or maybe they've changed that functionality since last I tried it. In any case, I'll show you how to get LibreCAD. I'll close this for the moment. No, we don't need this. Okay, there are many different ways. I use an operating system called Linux, and the particular distribution I have, it's a long story in its own right, is Ubuntu with the desktop called Mate. I find Mate is a very handy desktop in the fact that if I'm looking for applications, they're sorted in the type of application as opposed to some other sorting. On Windows it's sorted by vendor, same with Apple. And I find the menu system is very logical. I mean, you've got three major menu options here: applications, places, and system. So if you wanted to do some administration, control center is kind of machine settings and system settings. For administration, there are other applications for various things. Now we've got AppGrid and Software Boutique are kind of set up as simple and easy to use software installers, but simple and easy to use does not equal fast, in spite of what you may be used to in a graphical user environment. There's also a more thorough graphical user interface called Synaptic. For the purpose of this exercise, I'll show you Synaptic, which is more detailed. I have to give administrator password. I'm running a dual monitor system here, and I'm running one monitor at low res so I can do this capture for you. So yeah, I'm fighting resolution all the time here. Okay, let's go. I can go search here for, I don't know, CAD. Let's do that. And you can see there's quite a exhaustive list here. Now the package we would be after is LibreCAD. So LibreCAD. So what I could do is then click on here and say mark for installation and go apply. That's one way. Another way, I'll just close that of course, another way is to open a terminal. This is my favourite method. If you know the name of the package, which you now know, you have to install software, you have to get on as administrator. So sudo is a way of getting on as administrator. Sudo su stays that way. So I'll type that, it'll ask me for a password. The tool is Advanced Package Tool or apt-get, that's the program. Install is the instruction I want to give it. And what do I want to install? It's LibreCAD. So if you know the name of the package, you type apt-get install and whatever your package name is, and it's check what's available, and if it's available, it starts installing it, and Bob's your uncle. It is now installed. So if I was to launch applications, graphics, here you can see the sorting. There should be a LibreCAD in there. There we go. There's LibreCAD. And you can see it has a lot in common with QCAD. So let's say I'll go to draw a line. That one. The snaps aren't quite so smart. So, I mean, although the functionality is largely the same, it's not picking the, say, the intersection there like that. So there are all sorts of advantages. Here are the snaps you can see. So you'd manually pick, intersection. So it'll jump to the intersections, which in its own right kind of means it'll obey your thoughts rather than being kind of dynamic and having its own mind. But I do find QCAD's intelligence isn't too bad in this regard. Okay, so we can use LibreCAD, we can use QCAD. The layout's slightly different, but the fundamental functionality behind it is very similar. I don't care what package you use can use TurboCAD for all I care. But I'll show QCAD because it's my favourite and it works very quickly. And of course you can use LibreCAD, we don't need to use that. Okay, so I'll close all this down to simplify and close that, bye-bye. So here's our sketches, here and here. And I'm going to be struggling with a lack of screen space. Here we go. Now let me explain this interface in enough detail. I don't want to spend too much time on it because you may have a different system. But QCAD is very different from, say, many other packages. If I want to draw a line, for argument's sake, notice there's a little arrow on the right hand side of this icon. That arrow means there'll be more to come. And you can see these are many different kinds of lines you can draw. Now if I go click on that line, it shows me the snap options. So what happens is it swaps. I can go back and right click goes back. So I'll do that again. Pick a line. Right goes back, back, back. If I were just to draw a circle, centre, some sort of other point on the outside, click, back, that's a right click, back, another right click, and so forth. So if you see things bouncing back from these menus here, or these icons here, it's me right clicking. So right clicking is really, really fast as a forward and back method on QCAD. I really do like that feature. Let's say I was to do a dimension. Here's one thing that it's quite good at. I start drawing a dimension line. Let's say I pick on that spot and I go over here and that's the wrong spot. I right click, it releases that. Click on this other spot. Oh, no, I don't want that one, I want that one. You know? And so right clicking just lets you step back one step. It's very, very fast, very hard to beat this kind of performance. Now you can see, I'll zoom in here, you have the choice of the end or the intersection, so you do have to keep your eye out when you've got close points that its automatic detection is doing what you want it to do. That's on a grid line as well. Intersection, so the end may show up as an end or a grid because they are on a grid line. That line's on a grid line. Okay, so you can see it's pretty smart. We may also have a limit here. Where are we? Reference. Okay, so that's in reference to the circle. It'll be the left-hand edge of that circle. Yeah, so it's pretty smart with the way it snaps to things. I'm near a grid line, so I pick the grid line. The other thing it does, if I zoom out, it'll change the grids to, so this is showing 10mm grids, whereas before it was showing 1. Zoom out further, it'll be showing 100mm grids, 1000mm grids, etc. as you zoom out further and further. So the grid is adaptive, it's not a fixed thing. Okay, well enough of that. I'm right clicking to go back to the beginning. Now one of the best things you can use, now I'm zooming in manually, wherever you put the mouse, if you zoom in, it'll keep where the mouse is steady and move everything else accordingly. So you can see that is going in and out, being static on my mouse. If I put my mouse here on the center point, that'll be static, regardless of how I zoom in and out. Now I'm using the scroll wheel to zoom in. We can grab this bar here to scroll, or we can simply move over it and use the scroll wheel there. Same with the horizontal. So it's all very easy to zoom in and out. I find this is very, it's very fast. Okay, as I was starting to say, I quite often get ahead of myself here, so forgive me. Important thing to do is make multiple layers. Now the layers, I have my way of doing things, you may have yours, and I'm not aiming to restrict your style. Do what you want to do, but I want to show you in concept how to handle them. Okay, so what I normally do is create what I call a set out layer, so setting out the lines, and I usually make that green. Okay, just otherwise I leave it default. Okay, so what would I do with that layer? Now looking at our two sketches, I could do two things. I could either think around the front elevation here, looking at it from the front, or I could think around the plan view. So elevation, which has an upward dimension, or plan view, which shows the top view of a plan or a plane. Okay, so I'm going to do a line. Begin at the beginning. A line. I've already got it set to 10,000 long, and up here it's set to the end point. So that would draw the line downwards. I want to draw it upwards. So I'll press, click on the start. Okay, so I've just drawn a vertical line at 0, 0. So if I zoom out, you can see the scale here in millimeters. I'm starting to see the scale of what would show the product that we're going to draw. I'm going to right click and pick horizontal line. So now all I've simply done is drawn a vertical line and a horizontal line at 0, 0. 0 across, 0 up. Okay, and both those lines are 10 meters long. I'll zoom out till you see the full length of 10 meters. Now, looking at this job, the ceiling height that I noticed I've written on my sketch here is 2400. Okay, so it's 2.5 meters roughly, 2.4 meters. Each one of these dots is at a 1 meter space. You can see 1,000 millimeters, 2,000, 3,000, yada yada. Okay, so I'm going to draw another horizontal line at the 4 meter mark. It'll make more sense as it gets going. Right. Now that's where I intend to work as the back wall of this plan view. Right. Now the depth here, because that example that I drew in my previous video was done sort of about quarter size of a real object, refer to that video for why this drawing looks like this. I'm going to just simply multiply the real numbers that I measured by 4. So those numbers are going to be 177 and 570. I'm really going to ignore the other properties here, and it'll be a bit of a kludge of those dimensions, but yeah, it'll make sense If you refer back to the other video to see what this means, forgive me for the kludge of the numbers. Okay, so I've just gone right click to go back, and you can see the icons change. Now I'll say that again, this is a big asset to this program. A lot of programs have like 100 icons in front of you, just line after line of icons, and you can't use 3/4 of them. They're grayed out. Whereas QCAD simply hides the icons you can't really use by not having them present. Here you can see a couple of grayed out ones, but that's in essence because the other icons that are relevant here still are useful. When I go to draw a line, I'm obviously not drawing a circle, so everything that relates to, say, a circle has disappeared. But what options do I have here? Well, there are a lot of lines. I'm going to simply use parallel line. Now, looking at this front view, well, it's not really an elevation, it's a 3D perspective, because it's showing 3 dimensions: the depth, the width, and the height. But in essence, the front view here is going to give us information for the front elevation. So the kick is 100 millimeters. The ceiling height is 2400 millimeters. So my first parallel line I'm going to draw is in fact going to be 2400, and that'll give us the ceiling height. So that's the ceiling height. Now the kick was 100. Let's have a look at that. 100 on the bottom here. So I'll do that as 100. Now, okay, I went too quickly. When you get near the line, that is the existing base line or zero line, and I want a 100 millimeter line. As I get near it, as soon as it's decided that's the line, it'll draw what it's going to draw for us. If I was on the underside of that line, it would go downwards, upper side, upwards. Same would apply for left and right of a vertical. So that's how I produce those parallels. So we're going to do the kick. We've got a space of 100. That relates to that 100. So upwards of 100. And the bulkhead is 150. Referring back to this, 150. So I'll draw that. Okay, so I've got the bulkhead height and the kick height. Now, the opening width is 570 on our sketch, which I'm going to multiply by 4. So to do that sort of thing, you can go 570 times 4, which gives you an example of how you can get the CAD program to do the calculation for you. Most programs will do pretty much exactly that. So I've done that by 4. So now we have the width of the opening, the height of the opening, the bulkhead height, I'm getting all those lines, the bulkhead height and the kick height. Now what we need also, I've nominated 30 mm infill, so let's do that. I'll draw a parallel of 30 millimeters in from that side and in from that side. So that represents the width of the 30 mm infill. Let's go there. So you can see also here's 30 infill written here. So now, but these aren't the real drawing lines, these are just to give us the dimensions to work to. Now as you can see, we're getting quite a few lines together that are very close to each other. So to make the lines more recognisable, what I'll do is I'll create another set out line, but this time I'll just call it set out. Now you see how it's alerted me, there's that layer already exists. I want set out 2. Now it's happy, and I'm going to pick, let's say, red. So we've got a different colour for the different layers. So now we've got a 0 layer, which is a default layer, which I tend to actually not use, funny enough. We've got a set out layer and a set out 2, and you can see the colours shown as a little bit of a patch here. Right, now let's, on set out layer 2, we'll draw the thickness of the board in. Now it's important, I actually don't know how well to stress this point. So many people bring me drawings as a cabinet maker, and they sketch what they want, and they just draw any uprights as a single line. Meanwhile, everyone's left confused as to which side of the line a dimension is referring to. It's important to always include the thicknesses of your materials when you're drawing things. If you don't include those thicknesses, things get out of control pretty easily. So okay, now I've done my little preach. There's 16 millimeters as my parallel distance. We're using parallel lines. Now I'm going to zoom in so I can see the detail. there we go, 16 millimeters down from the underside of the bulkhead, 16 millimeters in from the left hand infill, from the right hand infill, and up from the kick height. So they represent the thickness of the panels we're going to make this out of. Now, we can, in fact, do some calculations across here. Now, obviously, I want to make this into 2 cabinets, not 1. So if you look at that, there'll be 2 boxes, with each box having 2 doors. So what I'm going to do here is I'm going to get info. Now, different programs do this differently, so I'll be as generic with my comments as possible. I'm just going to measure distance point to point. So the left-hand side of the 2 cabinets to the right-hand side of the 2 cabinets, and you can see that's 2220. Okay. Now I'm going to go right click. That took me back out of info and back to our parallel lines. QCAD's very nice at keeping things sort of at hand. Another advantage I see in QCAD. 2220. Oopsie. Divided by 2. I mean, you could have done that in your head, I'm sure. So I'm just going to leave it like that. Set out 2. Actually, I might go back on set out 1, so it's kind of a primary. Now, just to check we haven't made a mistake, I'm going to go to the other line on the other side. So if I use that line, it'll be there. That line's there. That line is there. Okay, so that's in fact perfectly in the centre. Now we can also verify that by using info. Distance point to point. So we go from here. 1110. 1110. So I've definitely got it correct. Okay, so now we've got the joint between the 2 cabinets. I right clicked to go back out of all of that. I'm going to draw a line again, parallel, 16 millimeters on set out 2. Both sides of that cabinet line. Okay, so we're starting to flesh that out. So I've essentially got the primary dimensions I need to have in the set out layers. Now we can make layers for the parts. Now there are two approaches for layers that I have seen. I tend to actually, I actually tend to set up the layers describing the types of parts. Now, for argument's sake, I make a layer for anything that goes horizontally. It's a very original name called horizontal. With QCAD, if you leave the line black and you have a black background, it'll actually draw the line in white and vice versa, but it means it'll print black on white paper. Okay, so anything that's horizontal, I have on the horizontal layer, and verticals, I'd have on a verticals layer. Now, the backs of the cabinets are also verticals, and let's say you wanted to show them separately from the other generic verticals, you might make a layer called back. So let's do that, as we can. I'm just showing you different examples of what you might use as layers, and perhaps you might have a layer for, say, dimensions. So dimensions. Well, let's leave it at that. We'll probably make a few more as we go along. Alright, now, difficult to explain in this CAD drawing because all it looks like is a bundle of lines at the moment. So let's start fleshing it out as parts so you can start seeing them. I'll zoom in as large as will work. There we go. I'm going to right click so it goes from the parallel line to just the generic line choices. One further, and I'm going to choose rectangles. I'm going to use that rectangle. Okay, and I'm going to do this on the horizontal layer. Now there's a cabinet top. It starts at the top left hand corner of the cabinet and goes to the right hand side of the cabinet, but goes down that 16 millimeters, so it's 16 millimeters thick. So if I turn off all the layers and turn that one layer on here, we've got that top drawn in. So I'll turn all the layers on, all the layers off, horizontals, on. Set out, on. Set out 2, on. So you can control what you see and basically clear the clutter and highlight exactly what you need to see. And it's for this reason I don't draw hidden detail lines. Now here's the other approach you could have to lines, or layers I should say. You could perhaps have a layer for sections. You could have a layer for dimension lines. I've got dimensions. You could have a layer for hidden details. You could have a layer for hatching. So you could identify them as types of lines, which is a common practice. But we are making something here, so I tend to want to identify them by the part type. Okay. I don't care which approach you take, that's your business, but I want to show you how the layers work. Okay, so we're still on the horizontal layer. Actually, I might make all the layers visible, so I can do what I have to do. Now I'm going to draw the floor or the bottom of the cabinet. So if I turn all the layers off, bar the horizontals, we have the bottom and the top. Okay, now the back, I've just changed layers. I'm still set up for drawing rectangles. They're calling it polyline, but there's what kind of polyline it is. It's a rectangular polyline. Now the back is going to go from the left hand edge to the right hand edge. Oh, it's not visible. And it's going to go from the underside of the top to the upper side of the bottom. So now we've got the back drawn in. Now we're going to do the other verticals, which is going to be an upright either side. I'm going to turn set out 2 on so I can see those red lines, and as you can see it shows me what I need to know as far as the dimensions of that other component. Now I'm just left clicking at the moment. Zoom out, zoom in, left click, left click, right click to go backwards, back to the main menu. Okay, so I'm going to make set out invisible. So there we have it. If I turn on and off the verticals, I did that on the back layer. Mistake. So as you can see, I've made an error. There's 2 ways we can do this. I can go Control Z till those lines disappear. Okay, so we turn off the set out 2 layer, turn off the horizontals, turn off the back. Let's just stick with that method for the moment. So I've turned on the horizontal, and turn on set out layer 2. I wanted to draw verticals. Unfortunately I picked the wrong layer. So here's the correct layer. Polyline again, rectangle. Left click here. Left click again. Okay, so I'll turn off set out 2 again. I turn off the back, really nothing will change because the horizontals and verticals maintain those same lines. Turn off the horizontals, we are left with the verticals. And obviously at this resolution the lines are very close together, a little bit unclear. Okay, I'm going to turn everything back on. So essentially have the box itself drawn as far as what it looks like from the front. Now looking at the line that I started with above here, let's draw some set out in. That was 177, which we're going to make 177 times 4. I'm going to go back here, back. This is, every time I went back, it's a right click. Draw parallel. 177, again times 4. I don't need to know the answer. It just showed us that briefly there. Okay, and I need to draw that on the set out layer. Okay, so that is the depth of the opening. Now there's a bit of a taper on this side, so I'm going to draw a bit of a funny line just to make it clear that's what we're doing. From the front, just nominally to there. This is only for the purpose of us seeing that it's a crooked wall. Okay, now here we go. I'll make another layer. Wall. And I'll make this blue. The colour is arbitrary, whatever you want to do, that's fine. Okay, now we're still on the line that I'm after, the line type that I'm looking for. I'll go here to here. Intersection it's picked. To this intersection. To that intersection. across randomly to maybe, okay, is it going to give us, I'm zooming in until I get a grid line that'll do the job. Okay, so that's that. I'm going to turn everything off, so only the wall is showing. Now that isn't much of a drawing for us to understand, so let's just draw some parallels to that. I'll draw, pretend the wall's 100mm thick, doesn't matter. On there, there, and there. Okay, so I've drawn parallels, right click, right click. Now I'm going to use these edit tools. This tool here joins two lines together like this. So I clicked on this line, clicked on that line, and it extended them to meet each other. Same here. Now these two lines it'll shorten to meet each other. So you can see that how that worked. Now I need to just join those together with two lines. First line. Right click, just release that. Right click again. Okay, so now I've got the walls. So I'll show you another feature. Right click to go back. There's this hatch business. I'll just draw a line around it. Hatch. I've got a scale here of 10. That works quite well. Okay. So we've got that wall hatched in. That was a very easy task, as you can see. Now if I turn the setup layers back on, well, actually I'll just turn everything back on. So you can see that's our wall we've got to work to. Now, obviously our cabinet has depths involved. Okay, so I have the wall hatched in. We obviously have a setback, which I'm going to make 20mm. So let's start with that. We'll draw a parallel. Make the distance 16mm. Oops. And I'll do it on the set out layer. Yeah, that's enabled the right way. Actually, we'll draw the thickness of the back. I just realised I made a small error. Change that to 20. From the front, back to 16. Okay, 40mm is how far I want the kick to sit back from the front of the door. And I'm going to cheat simply by using the back edge of the door as my guide for the back edge of the kick, because they're both 16mm thick. If I needed some other measurement, I could have typed that in. Alright, so that's showing me the distances front to back. Right click to clear all that. Yeah, so I've got the thickness of the back. This distance here is the set out from the setback from the front. The thickness of the doors, the distance that the kick is set back from that edge, and so forth. So I'm going to make a new layer. Let's call it, I don't know, kick and a bulkhead. I'll just use the same layer for both because they're doing the same purpose. Let's make that, I don't know, cyan. There we go. Let's draw that in. Polyline rectangle. So here's the kick. Now that's theoretically into the wall, but I don't really care much about that. It's just so we know what we're doing. There. So I've drawn both the kick and bulkhead by doing that. Right. Now the same way that we split the whole cabinet in half to get this line, we're going to have to make the doors. But the doors are a little bit tricky. Maybe I'll draw the infills first so you see the problem. I'm going to add a layer. I'm going to make it yellow and I'm going to call it face. Okay, let's do that. So I'll draw a rectangle. Go on the face layer. Now, the infill, looking at this drawing, is a strip on the side, on either side. Okay, so let's draw that infill in at that position. That's one infill on the left hand side. One infill on the right hand side. So that's that. Let's draw the horizontals in this plan view. Now the way I assemble the cabinet, tops and bottoms to the cabinets, if you look at my other videos you can see how I assemble cabinets. I have the the floor and the top extending over the uprights. So it's the full area of the cabinet. So I'm just zooming in here. The floor of the cabinet, or the top of the cabinet, is going to be the whole area of the cabinet. So it starts at the bottom left hand corner of the cabinet and goes to the rear right hand corner. So if I turn off the set out layer so it's a bit less confusing to look at, maybe even the kick so it disappears too. We've got the wall, we've got the infill in this space, and this represents the whole area that the cabinet will use. Okay, turn on the set out layer 2 and set out. Now we can see, if I go change to the verticals dimension, I'll draw the upright on the end, which you may call an end or a blade, I don't care, doesn't really matter, whatever you call the name. But it has to stop in front of the back. So here's the left hand side, or the left hand blade, and the right hand blade, it also has to stop that location. And then on the back layer, I'll draw the back. Okay. Now let's say we wanted to change the colour of something so the back looks a little bit different. Let's just click on the back and go edit. What we can do is pick some other colour. We can pick on, I don't know, let's say others. Let's do that. We can pick any colour we like. I'm going to pick, well, maybe one of these colours, or you can mix and match your own colour. We'll use a generic one. How about a purpley looking colour? Okay. Okay, so now the back layer is that purpley magenta colour. Alright, so I've put on a vertical here. It looks different from the back. And the horizontal, which shows up there, I'll turn off the back so you can see that horizontal now. So now we can, by turning on the different layers, we can see how everything interacts. Turn on the wall, and we've got the face. So these are the components that I've actually drawn, and the set out layers are just still here to set out our other dimensions. The kick and bulkhead, there's our kick and bulkhead. So if I was to turn off everything by the wall and kick and bulkhead, that's what we'd see. Okay, so I'm going to turn everything back on again. I might create another layer just to be more detailed, and I'm going to call this face set out actually. Let's call it face set out. What colour? Pick a colour, any colour. Let's go orange. There we go. Now the doors have a 3mm clearance. It's typical for these concealed hinges. I mean, you might go down to 2mm, but it's silly to go too fine because you'll have trouble. Okay, so the parallel line at 3mm. You can pick this line here. That's 3mm in from the left, 3mm in from the right. Now, of course, those lines show up both on the front elevation and on the plan view, so we can see them that way. Now, in the centre, the total clearance has to be 3mm. So what in fact we need is half of that. Now we can go 3 divided by 2, so as to make it half. It shows the answer just there as 1.5. That'll be fine. Let's do that. This side and that side. So that's another thing that's quite interesting and quite important to keep track of. What clearances you have on the doors. You can't just divide the cabinet by 2. You have to be aware of the clearances and how they interact. Here we've got a full clearance in the cabinet, and there we've got a half clearance. Okay. So to know the dimension that we ought to make the door, we have to include the clearances in our thinking. Alright, so what I'm going to do is use info, distance point to point. Now what I'm going to do is, if we think about this, the right hand side of this gap to the right hand side of that gap was 1108.5. 1108.5. Right click to go back, draw parallel, 1108.5. But we want half that, divided by 2. Now, to help make this a little clearer, I'm going to turn off every layer but our face set out. So I've got 2 lines here, 2 lines here in the center, a line on the right, a line on the left. So that represents the gap between the 2 cabinets. But to show how beautiful that calculation is that I just did, we just come near this left hand line, it gives us that one, come near the right hand line, and it gives us that one. And what we'll have as a resultant distance is in fact 3 millimeters. And you can see it's not in line with the grid, but is in fact 3 millimeters. So let's, we can do the same over here, touch near the side, near that side, and it generates our clearance. So you can see how using that calculation like that works rather well and fast for getting those numbers divided. It's a very handy approach for doing things like a baluster on a staircase. Those sorts of things, or stair treads, etc. are very well calculated the same way. Include both the object and any clearance you may have in your calculation, and then you end up with a good calculation both ways. Okay, so let's turn all the layers back on. Now we have enough information to draw the doors from the front and the doors from the top. Okay, so what I'll do here, I'll right click to go back a few steps, polyline. This time I want to be on face because I'm now going to draw the doors. Rectangle. Zoom in until we can see the detail we're looking for. This is the left edge of the door, and that is the right edge of the door. Okay, that's pretty good. Now let's look at our front view, our elevation. Bottom left corner of the door. Top right corner of the door. Okay, so there we have that. If I turn off all the layers bar the face, what we see now is we've got the doors, a door drawn in both views, and we've got the infills also drawn on the plan view. So I might get the infill drawn on the front elevation as well, so let's do that. Turn everything on again. Still on the face layer, I went to polyline again with the rectangle. Now it can get very confusing here, so you've got to keep track of what you're doing. Pays to be alert. Drinking and CADing is not a good idea. Alright, there's that. I might also draw the kick and bulkhead while I'm at it. Bottom left hand corner of the kick. Top right hand corner of the kick. Bottom left hand corner of the bulkhead. Top right hand corner of the bulkhead. Let's turn off the set out so it's less confusing. Give the face set out. So you can see now what we've got here is the bulkheads are visible. I haven't got the walls drawn in, but I will come to that in a minute. But what we need to do is 2 things. We need to repeat the cabinet. So we've got 2 cabinets the same. And we also need to repeat the doors because we have 4 doors. So let's start with the cabinet. I might just turn the face off and the wall. And for that matter, the kick and bulkhead. So I'm only left with what I need. I'm going to right click to let go of these functions, right click till we get back here. Draw a box around everything we're going to repeat. Use this edit tool, gives us a few options. Here we're going to do the repeat. So it's asking me for a reference point. Let's start with the left hand edge of the cabinet and move it to the right hand edge of the cabinet. So we've got a target point down here. Click on there. We're just going to keep the original. So in fact it makes 1 copy. So now we've done both of those. Now you can go through here, select. They say deselect all, or you could say select none. Select none. T being deselect, and N being none. So I can just type in TN and they're unselected. So there's our 2 cabinets. If we turn on the face, we see the doors still aren't repeated, but the doors have that kind of slippage because in the centre we've got the 1.5mm clearance, and on the left and right we had the 3mm clearance. So they are a different object, you couldn't simply repeat them. It doesn't play the same game. Okay, well, I'll get rid of everything else, bar the face. Now the reason why I wanted the infill drawn in is because it includes a clearance. A very important detail. That's a 3mm clearance. You have to obviously be working on the layer that you have visible, otherwise it's not working. Alright, so I've clicked with the left mouse button, I've left clicked, and I'm going to go to the top right hand of that. Now all the information I need for that space is already included here. As I said, we have to have that clearance of 3mm. So I've selected the door. You have the front view and the top view of the door. If I zoom in, you can see the infill is unselected. Same with the front view. Okay, now I'm going to copy it or move it. And what I'm going to start with is the left hand edge of this clearance, which is the space between the infill and the door. So that left hand edge, and then we're going to go to the right hand side of the door, but actually it's the left hand side of the next clearance. So left edge of the clearance to left edge of the clearance, and down the bottom here it was asking me for the various points, the source point and the target point. So if I right click, it'll go back. So it's asking me for a reference point, left edge of the space, and the target point is also going to be the left edge of the next space. As you can see, I've included a space now. This time I want multiple copies. I want 3 copies. So I end up with 4 doors. Okay. Now because we had selected the top view, or plan view, as well as the front elevation, we've got all those doors copied. Now I'll go TN to select none. If we zoom in, we should have all our clearances perfectly drawn in. All looks good. Okay, so the same will be true for the doors here. So sliding back and forwards, you can see everything should be a 3mm clearance. And if there's any cumulative error, it would show up here. Let's just measure that. From here to there is 3mm. So when you consider that CAD works in floats, floats have a habit of giving you a very, very small, a minuscule rounding error. And we've got a whole number of 3. So our calculations and everything are as perfect as the computer will come up with. Alright, so we've got the doors repeated nicely. We've got the cabinets. Let's just turn the cabinet layers on. There's the back, the horizontal, and the verticals. So we've got the cabinets drawn in, the bulkheads and kicks. Okay, wall. We've got the wall drawn in on the plan view, but not on the elevation. Let's draw the other elevation before we get carried away with walls. So I'll turn all the layers on so I'll get our setouts. Now a good trick for transferring from the plan view to the elevations is a diagonal line, a 45-degree angle line. Let's just do that. This line here, this angle, I've done this before. Let's remember the last time I did it. I might make that line a little bit longer, maybe 2000. And I'll just pick a point, maybe about there. There we go. And I'll do that on the set out layer too. There we go. Okay, so we now have a 45-degree angle line, which allows us to transfer lines down. Now an easy way of doing all of this is if you go along these lines, they hit that, our little transfer line. Okay, I'm going to draw verticals, and I'm going to switch to using end point. Okay, so if I pick that line's intersection, the next one, just carelessly I'm going to say, picking each one of those, making sure I'm accurately placed, but otherwise not worrying. I've got all those lines that we had on the front, transferred to being on the right hand side. Okay, so if we start drawing walls in, we can cheat a little bit with the parallels. We'll draw on the walls layer. I'm going to right click to go back. I went one too far. Parallel, 100mm. Now the trick I'm going to do is I'm going to draw the 100mm line, and then I'm going to use the 100mm line to go back and produce the other 100mm line at the beginning. same on the top. Do the reverse, bottom. So I'm producing, I'll zoom in so that makes more sense. So this is going to produce the 100mm line. Then I'm going to go to that 100mm line to produce a line back at the original location. So this is going to start to make sense shortly, I hope. Okay, so I'm going to do the same here. That's back from the front edge and forward from the back edge of the wall. Do that here. I'm going to make this distance a bit larger, maybe 500. Let's just do that. Forward and back. Alright, that should be enough information. Let's see how that goes. I'm going to turn off all the layers, bar the wall. Oh, it's a bit crazy and messy looking. Let's see how we go. Well, actually, we've done this wall to that location. We might do the same. We should have done that. Okay, now that's interesting. I can simply click on that line and it's highlighted. We can then edit that. And what I'm going to do is go from this source to that destination. Delete original. Okay. TN, select none. Okay, so there we've got those lines. Now that looks a bit like gobbledygook. Let's sort this thing out. Now the ceiling actually keeps going through, but the wall returns and so forth. So let's try and make this clear to the user. Alright, I'm going to draw a vertical and I'm going to use the wall layer. I'm going to use the start point. Okay, let's just do that. Now I've got 1,000,001 lines. Let's make some clarity. We'll go back to editing. Now these lines here I don't want to keep here anymore. Above this line I want them to terminate. So I'll use this tool, which basically shortens or lengthens. It says down here, choose limiting entity, which will be this line. If I click on that line, it'll stop there, etc. I'll just actually do that just to get some sanity here. They won't be the final terminations, but I'll do the same on the bottom. I'll right click to go back one. So now I've got to choose a limiting entity again. Right click, go back one, choose limiting entity. Okay. Let me just see how this is going to work. Okay, I'm going to leave that at that for the moment as I sort myself out. I'm still finding my feet. This tool here lengthens or shortens two lines that meet, as we saw previously when I did the wall in the plan view. Do that here just to tidy it up. That looks believable. I might use this other tool, which is to delete a line segment, to take out this bit. And I may also, what else should I do here? Take that. Take these line segments out because they don't connect really. I'm going to have to bring that through. Right click. Use that one instead. That. Yeah, that looks better. Click. I'm going to, what am I going to do? Okay, clean these out. Just delete those segments. There's so many different ways of skinning a cat. Actually, I don't even need that line at all when I think about it. So I'm just deleting what I don't need. Okay, so this is kind of sort of the whole, looking at it from the end. This is looking at it from the front, in which case we don't need that. What do we need? Wall. Depends how you want to symbolise it. I don't care, it's up to you. Alright, I'm going to now right click, use this tool again. Alright, now we can select a contour. So things that join, if you click on that, it's selected all of that, and we can hatch that. Let's right click a few times so we get back to the original. Hatch. not close at point 0. What have we got wrong here? Okay, this area here is not closed. That's what it's asking us to fix. So I'm going to abort all that, escape, undo, no, TN, select none, there we go. Edit. So it told me the error I had made. I'm going to go here, select, contour again. That should be selected. Right click to get out of all this. Hatch. Use the same as before, that'll be fine. The same business here. Actually, what's that? That's a stray bit there too. Okay. Edit. I'll use this tool. Okay. Now you may have seen up here, select, I use TN all the time. And select contour is, again, T for select, C for contour. I click on that line, it'll pick everything that belongs to that. I'm going to right click till we get back to the original menu again. Hatch, yeah, let's do that. Okay, so that's kind of sort of showing our walls, and this being a line that sort of denotes the edge of the cabinet. So let's turn on the other layers again, turn off set out 2, set out and face set out, and you're starting to see how this all works together. If I just go as if I'm going to have a print out of this, let's go print preview. That's what it looks like. We can change it to being like black and white. We can get it to fit to the pages. Let's swap that to landscape. Go fit again. Okay, so this is kind of how you would see it. Now you can see how having all the layers enabled makes it a bit complicated for the user to understand what they're looking at if you're just showing someone a drawing of what it will look from outside. So you would turn off the layers that are not of relevance. So the horizontal, the vertical and the back are not relevant to this view, and you may find that they're relevant to that view. So you may play around with the layering to suit how you want to show the drawing. Okay. Now if I'm going to show a customer, I really only show them kind of the faces unless there are specifics of the internals that matter. Then I might show different views. So it all depends on what you need to show, what you need to see, so you'll have to enable or disable layers. Okay, but you can start to see how this is turning into a real drawing instead of just an idea. Okay, now at the end of the day what we're after out of a drawing is to perfect dimensions so we can make them. Make the object, whatever it is. Now, I'll get rid of this preview. Where have we gone? Preview. So here's our views there. I'll turn all the layers back on so I can complete this drawing so that we see what the end view, looking from this end across, would look like here. We have to borrow dimensions off the plan view as well as the elevation or front elevation. So this is going to be the left elevation, and in effect it's a section too. Like, it depends how you want to use the drawing, but in effect it's an end elevation or it's a section. You can choose what importance it is for you. Now section means what it would look like if you cut a hole through it, or cut a line through it. Okay, so I'll turn everything back on again. Let's draw the bulkhead in using polyline, rectangle, bulkhead, zoom in. Now the bulkhead occurs from here to there. I mean, you could put it elsewhere too, I'm just using that as an arbitrary place. That's the kick. Okay, now you might want to draw in a kick frame, I'll just leave it out for simplicity right now. Now on the face layer we have the infill, which goes from there to there. That also is where the doors are, so we don't have to draw any more of that. Okay, the horizontals. The cabinet top goes from just behind the back of the door to the wall, and the floor is pretty much the same detail. Okay, then we draw the back. Starts from the wall at the back, goes forward and to the underside of the top, and then the other vertical, which is the end panel or blade, terminates in front of the back. So if we turn off the setouts, it'll start looking a little bit more believable. Now drawing this again very simply, we might draw in a frame structure, whatever we need, and there's our section. If there was drawers, you might want to draw them in, or extra shelves, etc. You might want to draw those in. But in essence, we have now our 3 views, and as I was saying, the whole purpose of these CAD drawings is to know how the sizes of everything works out. So I'm going to turn the setouts on to face set out even. Go back to dimension layer. So this is the active layer. They're all visible. Right click to get out of all these functions. Use the dimension tool. Now I'm not sure what I've set the dimensions to. So I'll just start drawing a dimension because we can edit on the fly. Okay. I'm going to zoom in. The door starts from this edge and goes to that edge. But the number's wrong. Not clear enough. So we're in the middle of editing the dimension. And if I go right click, it takes it back one. So we're still in the middle of drawing the dimension. But QCAD is very handy. We can go and change those attributes. Edit drawing preferences. Dimension settings. I'm going to make the dimensions say 40 millimeters in size. So it gives a very good comparison to the original. Now you can see it's accurate to 2 decimal places because we can see 551.25. Again, going back to the edit drawing preferences, we can change the precision. Enlarge that a bit. I'm quite happy with the precision to stop at 2 decimal places. If I was measuring degrees, funny enough, I like about 2 or 3 decimal places on degrees. Okay. But that will do. Do we need to show trailing zeros? No, I don't think so, because it just adds confusion. Keep everything simple. Okay. So we're still actively in the middle of drawing that dimension while we're editing that. So I'll click on that location, and I'm going to just click 100 millimeters up. Just settle that position. Now we can test that every door is the same size. I mean, we know they are because we repeated them. I didn't draw them individually, etc. So you can measure all of them. You could also say measure the cabinet size. Again, using the set out line as our reference. The joint between the 2 cabinets is right there. And I might go to maybe 300 millimeters down. And then I might measure, say the customer might need to know how big the space is inside the cabinet. So let's just check that. Okay, so we've got that. We now know the door sizes very accurately, 551.25, which you might end up rounding to 551 depending on your production accuracy. 1078 internal, 1110 external. What else do we have here? Okay, we can draw the depths in here. So we can do the overall of the wall, and maybe put the dimension up a bit. The next size down will be maybe the overall of the cabinet. Oops, wrong one. I just right click to reverse that process. Overall of the cabinet to there. Then you might do the internal of the cabinet. Then you might also want to do the setback from the front of the cabinet to the kick. It's getting cluttered, it might do that elsewhere. Okay, so I tend to try and keep my dimensions as simple as possible. Yes, we need to know the overall opening. Maybe I'll put that. Let's see where it goes to. That's an overall. Let's do an overall at the same height. Okay, so their overall dimensions are in line with each other. Basically, any attribute you want to dimension up, you can. So that's just simply how that's done. So from the front edge to the kick is, say, 60 millimeters. From the front of the door to the kick, let's say 40 millimeters. Whatever you want to attribute these the drawings with, that's fine. Whatever you want to do. We need to have some heights drawn in. So let's go back to verticals. Do floor to ceiling. 2400. They might have into there. The internal height of the cabinet. Now, whatever dimensions you need, basically, to roll your own, suit yourself, whatever purpose you have in mind. So I'll turn off the setouts. We're basically coming to the end of the drawing process. Let's have a look at the preview. Make it fit the window. Now this is produced at 0.043. You may decide you want to have a particularly determined scale. That's about 1 to 20. So let's go 1 to 25 would be 0.04. Okay. So now you can see that has given us the drawing fitting nicely in there. We can manually move the drawing paper around to suit ourselves depending on what other stuff we want to show. But basically we have ourselves a drawing. And of course any layer you want to show you can or not, verticals or not, you know. So if we wanted to make it just showing the faces only, how am I back? Okay, so we've now got the back showing. Now you could also attribute these, say the dimensions of the doors. You may actually switch to the door layer. So we'll turn off that preview and I'll show you what I'm talking about. Right click until we're out of all of that. Click on that. We can change it to, from dimensions to say face. This one, dimensions to say face. So what that would mean is if we were to turn off the face layer, those dimensions disappear too. So you can see those dimensions would exist with our face. So that kind of thing you can do to suit yourself as well. So I'm not forcing that any particular standard upon you. Feel free to have the drawing attributed according to how you need it. Anyway, I think that's really sums it up quite nicely. My next video will show this done in a 3D CAD program. Yeah, we'll see how we go with that. There's our sketches. There's our resultant drawings. That's how it may look on a printed page. Yeah, well that's it from me. Feel free to like, share, subscribe, leave a comment, ask a question. Well that's it from me. Bye for now.